And okay. So good morning, everyone. And what I'm trying to do in our material section is I'm trying to organize everything into folders. All right. Everything I do tends to be a little bit slower than everyone else. But in this folder, I posted some problems, some exponent problems, and I did it on Sunday afternoon. If you didn't have a chance to do it, that's totally fine. I totally understand. Um, these were intended to be a little bit more difficult problems to practice with. So it wasn't like a one-step problem. You had to use a few of the rules at the same time to solve each of these problems. So hang on one second. So let me just check to make sure everyone. So what I was thinking about is, let me just kind of go back to, so what I was thinking about doing on Thursday when I see you, and oh, go ahead, Jen. Yep, yep.
Sorry for interrupting. I just
It's okay.
wanted to say that, like, you wrote in the updates that we were supposed to do things from lesson 5 folder.
Oh, did
So,
I? Oh, I'm sorry.
yeah.
Yeah, so sorry, that was, I meant, so that was a typo. It should be lesson 3, but that's okay. Like if you didn't have a chance to do it, that's completely fine. Um, with me, like for example, uh, let's say, let's say I assigned a homework and you didn't do it. It's okay. Like, life happens, right? That's the important thing. Even if you miss like 1 or 2 homeworks in a row, like my goal isn't to be like, okay, you should do your homework. It's more, um, hey, what's going on? Is there anything I can help you with? Was the homework too difficult? If there's something going on in your life that, that interfered, that's totally acceptable. Um, so homework should not be a punishment, right? So there's a very famous, I think he was a Chinese philosopher, and he said that rewards and punishment are the lowest forms of education. So my goal is not to make homework a punishment, just something to practice with. Kind of like if you were a football player, you'd want to get out and kick a ball a lot, or if you were a basketball player, you'd want to get out and try to throw as many baskets as you can, just to improve your skills. So like that's the only reason I do homework. Um, I am required to give you guys formative and summative assessments. So like, um, um, did I answer your question before I talk way too much, Jen? Okay, cool. Um, so what I would like to do, so let me share my screen again. Um, well, actually, first, while I can see everyone, let me do this. Um, has everyone had a chance to try 1 or 2 of the problems? It's okay if you haven't, like, but just give me like a thumbs up if you've had a chance to try. Oh, hang on one second. There's Yvonne. Okay. Um, so what I'd like you to do, look through these 5 problems. Okay, hang on, let me go back to screen share. If you could look through these 5 problems, which one, let's choose 2 problems to start our class today with, because on Thursday, I would like to give you like a 5 to 7 question formative assessment. I want to see how you are doing like with just this. So it will be on Thursday, just these type of problems. So like laws of exponents. And then I'll put like 1 or 2 logarithm problems. So like that's my goal for Thursday. So if you could, um, as a class, if you could choose like 2 problems to go over, and like, I know I didn't number them because like I think numbering math problems is sometimes hard. So the first one would be number 1, this would be number 2, 3, 4, and 5. So for you guys who've done this, choose a problem and let's go over it together. So I'm gonna do stop screen share for a second just so I could see everyone. So if you guys could tell me what problem you would like to go over, like which one looks like super hard, and which one can I help you with?
um,
You can hold up your fingers too. You can be like 1, 2, 3, whatever number you want to do. So I see 1, 3.
yeah.
3, 4, what, is that, we want to do 3 and 4 together?
Oh yeah, 4 actually. Never mind. 4. It's number
Okay,
4.
okay.
Yeah.
All right, so check it out. Let's start with problem number 4, and maybe we only need to do 1. If we need to do 2, that's totally fine. So let me do a screen share again. And let me just see if I can write the problem down. So is this the one like 5xy squared? Is it that one?
Yep.
5xy squared. I'm writing it down on a piece of paper so it's easier to transfer it. Xy cubed. All right, so what I would like you guys to do, just make sure that I'm first just writing this problem down correctly. Y cubed. This is supposed to be a 10, sorry.
Yeah, that's good.
Did I write everything down correctly?
Yes.
Yeah.
All
Yep.
right, hang on one second. I'm just gonna fix my screen really quick. 1, 7, 5. Let's try that. Okay. All right, now with this one, the very first thing I would do is I want to look for like a common base, like, and if I can see one, if I could actually see a common base right away, like I see I have like a 5 and I know there's a 10 down here. 10 is 2 times 5, so maybe there's a common base. But then I look at the next term, I see an x. Okay, I see an x over in the denominator, numerator denominator. But then this y term, like y squared over y cubed, this tends to mess things up. So the very first thing I want to do with this problem is, let me just kind of get a different color. So I'm gonna work with this. Let's do this actually down here. So the very first thing I'm gonna do, let's just take a look at this. So we have 5xy, this thing squared, and then I have that to the power -4. So the very first thing I'll do, and there's no right way to begin this. This is just how I see the problem. I'm going to distribute this -4 power to each of these terms on the inside, okay? So there's a rule that we have for that. And our rule basically says that you're just gonna do multiply the exponent. So I'll do 5 to the -4, x to the -4, and then y, and remember our rule, it's gonna be 2 times -4, okay? Which we know should be -8. So this will be a -8, okay? And then what I'm gonna do is I'm just gonna put this answer back up here so that we can just work with this one piece at a time. So -4 y to the -8, right? I'm gonna do the same thing for the bottom term. So I'm gonna look at this term separately. And you could do this right along. I just wanna like look at each term one by one so that we're on the same page. So like 10 xy cubed to the -7th power. I'm going to do one more step, okay? And I think this step will probably make it easier. How do I know it will make it easier? Because like you do a lot of problems and eventually you kind of see patterns. So you see this 10. I know that there's a 5 in the numerator, okay? I know that there's a 5 up top. So I'm going to just rewrite this one term here as 2, that 10 is really 2 times 5, okay? And so put parentheses around it. So I'm going to just like look at this term again. Okay. All I've done is I've rewritten 10 as 2 times 5. And now I'm going to do the same distribution pattern. So I see this -7, and I'm going to multiply raise 2 to the power 7, 5 to the power 7, and each of these terms gets that power. And when you do that, you should get 2 to the negative 7, 5 to the negative 7, oops. And then I'm going to do x to the negative 7. And then y is going to be, I'm going to just do this step out in my head. It's going to be 3 times negative 7, which should be negative 21. Okay, so that's going to be my bottom term. And what I'm going to do is I'm going to just write that up top. So this will be 2 to the negative 7, 5 to the negative 7, x to the negative 7, and then y to the negative 21. Okay. Does anyone have any questions on just this? And I'm going to do a stop screen share for a second just so I can see. Does anyone have a question so far on the steps that we've done? Any questions so far? No? Okay.
No.
We go back to screen share. All right. And now what I want to do is I want to work one term at a time. So I'm going to take a look at, all right, so here are my common terms. Here's a 5, okay? These have common bases. So I have 5 to the negative 4 and then 5 to the negative 7. Does anyone see a 2 to the 0 power up top? You guys see 2 to the 0 power? Because 2 to the 0 power is 1. So remember this, like 2 to the 0 power equals 1. And the reason I'm bringing that up is because there is a 2 on the bottom. One way to deal with that, no, let's ignore the 2 for a second. Let's just do 5s, okay? So we can write this as 5 to the negative 4. And remember, when we have a negative power for the term in the denominator, we can subtract, in this case, a negative 7. So we have 5 to the negative 7 in the denominator, and we're going to bring that term to the top by subtracting it, okay? And we have the next term is going to be x to the negative 4, and on the bottom we have x to the negative 7. So our rule says subtract that 7. So just as a little, I keep referring to a rule, like, and the rule that I'm referring to is, let's say you have two terms, a to the m power divided by a to the n power. So if you look at the slides, like whenever you have the same base, you can write this as a to the m minus a to the n. And that's what I'm doing with each of these terms. I'm going to apply that one rule. All right, so the next part would be y. Is that a negative 3 or is that negative 8? Is that a negative 8?
That's
Sorry.
a negative 8.
Thank you very much. So I have that negative 8, and I'm going to subtract. There's a negative 21 on the bottom. So I'm going to, and notice how I'm using my parentheses, because it's really easy to make a mistake, like just by adding or subtracting the number incorrectly. I'm going to go back to this 2, right? There is a 2 with like there's a 0 power right there. So 2 to the 0 is just 1. But I'm going to subtract a negative 7. Okay. So I'm going to just scroll over. So this should work out to be, so minus a minus 7 should be 2 to the 7th. So we have 2 to the 7th power. And then I'm going to do this term by term. I'm going to do it in a different color as well, so it's easier to follow. What's minus 4 minus a negative 7? So that should be plus 7, right? So it should be x to the 7 minus 4. I think it's 3, right?
Yeah. Yeah, it's 3.
And then how about the next one? What's the y term? We have minus, sorry. Sorry. I made a mistake there, didn't I? Let me fix that. I skipped ahead. So this should be, that should be 5. I'm sorry. So I should have written that as, so 5, it should be to the -3. Sorry, to the +3.
3.
How about that next term, x? Should basically be the same thing, right? -4 -7 minus a -7. I think this should work out to be that.
Yeah.
X to the 3rd power. And then how about that y term? What's 8
13.
or very good. So this should be your final answer. Should look just like this. If you were to multiply, if you were to basically take 5, raise it to the 3rd power, you'd get 125, and then multiply that by 2 to the 7th. What would that be? Like 264? Would that be like 4, like so it'd be like 428 or something? You don't need to multiply. This is a totally acceptable way to leave the answer, is in this form. Does anyone have, and I'm going to stop my screen share for 1 second. Does anyone have a question on that one? So this was a complicated problem. There was more than one thing that you had to do to find the answer. Do you guys have any questions on this one problem?
For the final answer, would you multiply 2 to the 7th and 5 cubed together?
No, you can leave that, but you can leave it as it is, believe it or not. So like, that's a good question. So like this, so you can leave this just the way it is. If you
Okay.
wanted to, you could, but like, so like, so 5 cubed would be like 125. And I think just off the top of my head, 2 to the 7th power, did anyone do that out? Because I think that's like 264 times 2, 260, hold on. Did anyone get that as a number? Does anyone?
Didn't try.
Wait.
What did it work out to be? What's 2 to the 7th?
It's 128, I think.
Oh, that's only, okay. Yeah, you could multiply 128 times 125, but that's a really big number. I mean, that's bigger. So
Yeah.
like, let me just show you a quick mental math trick. And this is how I do things. This is how I come up with estimates. I know that 128, it's kind of like close to, it's not exactly, but it's close to 100, right? Which is 10 squared.
Yeah.
I know 125 is close to 100 or 10 squared. So when I look at numbers, I don't try to ever calculate anything precisely, but I know 10 squared times 10 squared is like 10,000, which is a big number. And I
Yeah.
don't like looking at big numbers. So like when I see these numbers up here, 2 to the 7th times 5 cubed, to me, that's totally acceptable. Leave it just like that. Because you don't really
Okay.
want to write really big numbers. It's just a nice, easy mental math trick.
Question.
Yeah, go ahead.
Would the-
Who's that, Matai?
Mate, would the
Mate,
answer still
go
be
ahead.
right if we didn't change 10, and instead of having 2 to the 7th times 5 to the 3rd, my answer was 2 to the 4th times 10 to the 3rd, which works out to be the same thing, just not without 5.
How did you get, oh, wait a sec. Oh, so you did,
Yeah, I just distributed the -4, and after all I got 0.0016 x to the 3rd y to the 13th over 10 to the -7, which works out to be the same thing.
Matai, can you see my
Yeah.
screen? You basically did this, right? And then, so you then did like 5 to the -4th times 10 to the 10 to the 7th. Is that correct? Do you follow
Yeah,
what I'm
sort of.
doing?
Yeah. I
Okay.
just
And
the answer works out to be the same thing.
okay, yeah, like so, like,
because you were
that's
talking
fine.
earlier about 128 times 125, which is 16,000, which was exactly what I got, and then I just put it in terms of powers.
Okay, yeah. So okay, I understand what you're doing then. that's fine. Like, but to save yourself some steps in a calculator, or just like not necessarily calculator steps, just like to simplify, like if for lack of a better word, to simplify life for yourself and for everyone. Leaving it in this form is completely acceptable, and to be honest, it's probably preferred. So if you were given like a test with like, like this would be like a multiple choice question. If you were given this question and um, you might only see like a potential answer in the like this form, 2 to the 7th, 5 to the 3rd. So like you might not see it in the other form that you had it, like where you factored and multiplied. So uh, leaving it in the form that you see is probably preferable.
Okay. Okay. Thank you.
You're welcome. Is there, let me just check the time. Is there one more that you guys want to do? So what is that? Does that class end at 9:15? Is that when it ends? All right.
Yeah.
How about let's do this. There are a few more logarithm problems that I would like to do. And then if we have time, we can go over one more problem from like from those 4 problems. I'll post solutions either tonight or yeah, I'll post solutions tonight. Okay, so I will do that. Right, and then if you guys have questions, you can email me. All right, so if you guys could open up the PowerPoint, so I think, or the PDF. Did we do these problems like log 10, the 10,000, and like
Yeah.
we did these ones? Okay, cool.
Those are the only ones we did.
Say it again.
Those are the only ones we actually did.
Okay, that's fine. So what I want to just talk to you about, okay. So hang on one second. All right, so I just want to give you just like where do these things come from? So like, let me ask you a question. What's 10 to the 0 power? Just quick review, just kind of shout it out. Yeah, 1. How about 10 to the 1st power? Seems silly, but what is it?
10.
10. And 10 squared, what is 10 squared?
100.
Good. And 10 cubed is
1000.
1,000. I'll do one more. 10 to the 4th power, what is that?
10,000.
10,000. And we could keep going, right? All the way to the very last 10 to like 100th power, which would be a Google, and 10 to the, we can make some really big numbers. What I'm hoping that you'll see with this is, math is the scientific study of patterns. Like, so what does math do? It looks for patterns in nature, and then it invents patterns that it sees. So like, as a review of what we started to look at is we talked about the logarithm, okay? The logarithm is like a function, and what it does is it's what we'll call like an inverse function. Like we won't talk about that today, but the thing that I want you to get away from using logarithms, and like this is a problem that we did. So this is called log base 10, okay? So like you'll never see this like if, hold on, let me erase that so do a different color. So just like right here, where like we never say, like we never write 10 to the 1st power. We always just know that's just 10 to the power 1. So like these two things are the same. This is called log base 10, and that's how we read it. We say log base 10 of 1,000. And the thing I want you to take away from this is we can always rewrite this as log times 10 to the, in this case, 3rd power. And what this does is, now I'm going to do one additional step I don't think I did Thursday last week. We can write this as log of 10 times 3. So we did this step, so there's a 3 here. Whenever you see this, so like whenever you see log, sorry, different color. Whenever you see this term log 10, like you have 10 in this argument form, okay? This number right here is equal to the number 1, okay? So we can, so this step where we can write as 3 times 1. So this is just an extra step. These things, this thing is just equal to the number 1. So like, let me write that down. So log of 10 equals the number 1, okay? Log of 10 squared, which is 100, equals 2. Log of 10 cubed equals 3. And the reason for that is we can always rewrite this as, well, this first one I don't need to do. I could always just write this as, 2 times log of 10, which is log of 10 is just 1. I could write 3 as 3 times log of 10. Log 10 is just equal to the number 1, okay? So you see how there's just a pattern to all of these problems? Now, the one thing that we cannot say, here's the important part. How am I going to do that? Log is, so sorry, no, I don't want to say the next part. I want to do one more problem with you, and I think we might have done this already, but actually for time, because we only have 15 minutes, let me do this. So let's say we have log of 0.01, right? How would I write 0.01 as a power of 10? So I could rewrite that as what? Just kind of shout it out.
10 to the negative second.
10 to the negative second power, or 10 to the negative 2. And all you're going to do is you're going to just do the same thing that you have been doing. You write this as that exponent, okay? So like log of 0.001, all right? Rewrite that as a power of 10, okay? And that should be log of 10 to the minus third. And that you're just going to write that as minus 3. Okay. And we could keep doing this forever, and then eventually you'll see the pattern. So log of 0.0001 would be log of 10 to the minus 4 power, which would just be minus 4. Okay. So oftentimes I don't memorize very many things. Whenever I get stuck, I always look for patterns. And that's what you want to do. Whenever you get stuck, look for patterns. If you don't know what the pattern is, like let's say, hang on one second, let me show you something else. So I'm just going to open up another thing here. So I don't know. I don't have a calculator. Like I use my phone as a calculator. So, but like just to show you with this, I have no idea. So whenever I'm not certain, let's see on this one, I think they probably have this in the function section. Yeah, they do. So whenever I'm not certain about what I'm supposed to do, I'll just be like, okay, find a calculator. All right, let's put a number in. Like I know that if I start with the easiest number, I know 1. Let's see what that works out to be. Oh, log of 1 is 0. Cool. If I'm like, okay, what's the pattern? What's log of 2? I don't know what that is. Oh, it's that. Ooh, I don't like fractions. I don't like numbers where it's like 0.0 something. All right, so I'm going to go to the next one. I'll go log of 100. So if you have a calculator and you're allowed to use a calculator, just start plugging numbers in. Look for the pattern, okay? That's the important part. In math, always there is a pattern. Look for the pattern, okay? If I do log of 0.000000, I'm gonna just put a big 1. Cool, that's like -10. So look for patterns, okay? And if you have a calculator, if you're allowed to use a calculator, use it, okay? And look for patterns. Now, kind of going back to our shared screen. All right, now there's there's two important logarithms that we'll talk about. There's log base 10, which is what we've been doing. So log base 10. Do you remember when like we were looking at these exponent problems and like, you know, I think we had a slide, you had like 3 to the 5. We called this your base. All right, and then this is your exponent. All right. Here is your base. Your base is 10. Like we never write it though. We just say like log base 10. All right. There's one other logarithm that you'll see a lot. So like sometimes you'll see log. We never write it like this. Base E. All right, I'll tell you what E is in a second. But we write this as just ln. All right. And like, you know, whatever the number is on the inside. Okay, so we call this the natural log. Okay, or the natural logarithm. All right, and the best way to explain where does this come from, let me, like, we talk about the number pi a lot, right? Pi is about 3.1415926, and a lot of other numbers. It goes on forever. This comes up in nature all the time. If you want to calculate the large scale structure of the universe, you need to know what pi is. If you want to calculate the orbitals of electrons around like a hydrogen, a helium, a lithium, like any type of atom, you need to know what pi is. And I think we talked about this in class. Any circle that you measure, so if you measure the circumference divided by the diameter, you always get this number. It's a number that shows up a lot in nature. This other number here, E, what we call it E, this is about 2.71828 and so on. It goes on forever. This number shows up in nature all the time. And that's why we have like this other form of the logarithm. So we have this thing called log base E, okay? So like as an example, and like let's say you had like the natural logarithm of e to this, I don't know, e squared. Well, this just works out to be 2 times the natural log of e, all right? And then this just works out to be like 2, okay? The same way that our other like log 10 works out to be 1. So like, check it out. Go back to this. All right, so like you have this other logarithm, and believe it or not, I work with the natural log. I work with this thing in physics more than I work with a log base 10, okay? We're just gonna practice with both, and that's the important thing is like, they're basically the exact same thing. Let's see what I want to say. Yeah, we're gonna do some problems with this, but we're not gonna do them today. So this is just kind of like a precursor lesson to a bigger lesson on exponents. So on hang on a second. All right, so on Thursday, you guys can see my screen, like you can see my draw screen. Yeah.
Yeah.
I can. Okay, cool. So on Thursday, you're just gonna have. Actually, it's probably just easier to show you this way. So I'm thinking like 5 or 7 questions, and so you're gonna have a few problems like. Hang on a second. You'll have like 1 or 2 problems like this, okay, where like I'll be like, what is the logarithm of say 10,000? All right. For the test, like no for the test, no calculator, because but I'm not going to try to trick you on anything. So there'll be like maybe 1 or 2 logarithm problems. And then you're going to have problems more like this, like where you'll be like, okay, simplify this expression. Um, you'd have a problem like this. So like if I do like 4 or 5 problems, they're going to be like kind of one-step problems. Okay. I will put one difficult problem, and that difficult problem might look more something like, let me find it. Can you guys see, like I put the problems that I put up, posted earlier? So like you might see like a problem like this on the quiz. So like just one of those, just to see who's like where people are at. Okay. Let me just check the times. Okay, so we have like, give me 1 second. So we have 7 more minutes. Is there another, well, there's one, does anyone have any questions first? Are there any questions on like logarithms, exponents, or what we'll do at the beginning of class on Thursday? Any questions? No, yeah. All right. Would you guys like to choose one more problem for me to go over from the list? Is there another problem you want me to go over from the homework? So if you guys want, like, you can put fingers up. I can see you guys now.
I'll just check the problems.
So problem number 1, I see one finger for number 1.
Oh, no. I was reading my hand. I mean, sorry, finger number, not
okay.
finger, sorry,
Okay.
problem number 2.
Number 2. Yeah, no, I was actually going to, believe it or not, let's do number 2 because my other class had some difficulty with that one. So hang on, let me just write this down. So number 2 is that 25x plus 5x squared over 5x. Okay, let me go back to my draw screen. All right, so just make sure I'm writing this problem down correctly. So I think it's 25x. Oh, yeah, 25x plus 5x, that thing squared, divided by 5x squared, okay? There's one important thing, and I'm gonna do this on this, like below this. So let's say you have a plus b over like c, okay? Just like these are numbers. You have to rewrite this as a over c plus b over c, okay? So like that's an important like rule before we begin that we have to observe. So I'm gonna just like leave this as a 25. Actually, let me simplify one thing. This thing down here, all right, we can write this as 5 squared over x squared. So let's just make sure everyone's like can see that. Like I'm just distributing that term. All right, and then what I'm going to do is I'm going to break this up into put a 5 squared x squared here plus 5, the next term 5x squared divided by 5 squared x squared. Does everyone see what I did with this one?
Yes.
And the reason I bring this up is because I had a couple of students, what was the step that they did? They just didn't see this step right away. So like, just be careful when you have numbers like that. Let me ask you a question. 5 squared is what, 25?
Yes.
Yeah, so like, so for this first one, I'm just gonna skip a step, right? I have 25 here and 25 here. So I'm gonna cancel those out. And then I just have x over x squared. And then here, like this term, I have a 5 on the top and a 5 squared here. So I can cancel out the squared term. and cancel that out. And so what I have then, oh, there's another common term. I can x squared. So I just have this thing. All right. One more step to simplify this. I can then go, it's a different color. I have x here with x squared. So I could write this as just 1 over x plus 1 over 5. Now, if I said to write this with negative exponents, like, like for this problem, you could leave it like 1 over x plus 1 over 5. Or you could write this as x to the minus 1 plus 5 to the minus 1. Both of those are equal. You can, either way would work for this one. Any questions on this one? Any questions on this? Hold on, let me go back to this. Looking at everyone. Does anyone have any questions on that?
Wait,
Sorry,
could
let me
you
go.
show the answer again, please?
Yeah, sorry. So these are both valid ways to write the same thing. So like these are the same, these two things. When in doubt, just write it like this with like the negative terms, unless it says write it without negative terms. So in this case, like I do not have a preference, just like kind of go with like, what does the rule say? Like, or what does the instruction say? Does it say no negative exponents, or so that's what I'm looking for. Like I follow your work, so like I look at what people do, and when I'm kind of like grading your homework. All right. So check it out. It's 9:14 now. Later on today, probably by lunch, or not lunchtime, by dinner time, I'm going to post some solutions. All right, that way you can check yourself. All right. Is it okay if I stop the screen share?
Yes.
Okay. If you have questions, like after looking at the solutions, like send me an email, and maybe we can set up some time to meet tomorrow online. Okay.
Okay.
If there's no questions, you guys are free to go, and I'll see some of you in physics, and some of you guys I'll see on Thursday.
Can you just put
Bye.
the homework as an assignment on Schoology so that we can remember to do it?
Yeah, I'm still like bear with me. I'm still learning how to use Schoology. So yeah, like hopefully for the next one, I'll make sure that I do that.
Okay, thanks. Because it's like hard to remember sometimes that there was homework.
Yeah, sure. Like yeah, like if like if you didn't do it for today, that's okay. Like it was my mistake.
Thank you.
Thank
You're welcome.
you.
You're welcome. I'll see